Welcome back to the BackProp podcast. It's a special episode today because we have one of our investors and close friends, Vig, here joining us. And so we'll go into a lot of good conversation about what it's like to be an investor, especially in the AI space with it being so hot, as well as personal story of how you got into it and things that are exciting you. Yeah, so welcome to the podcast.
Thanks for having me. It's good to be here.
So I guess to kick things off, we'd love to just get a quick background story. Yeah.
Sure. Yeah. I met the LastMile team. It's been I guess almost 2 years now, right?
Yeah.
I work at Gradient and I'm an investor there. Before that, I spent about a decade working as an engineer and researcher in the machine learning space. I was a researcher over at Microsoft where we worked on some solutions for Azure.
Nice.
And did my PhD over at Stanford where I worked on research at the intersection of machine learning and distributed systems. So definitely still a hot space in terms of a lot of developments, a lot of news, a lot of things to keep your eyes on. And I also worked on 2 startups that were about to spun out of academia.
Nice.
So one came out of MIT and it was a machine learning startup for the retail space.
Nice.
We ended up working with a lot of the largest retailers in the world and got acquired into Nike. And the second startup is a distributed systems startup that was spun out of Stanford, and it's still growing and still building to this day. So it's been my past. It's been really fun, seeing how far the collective community has taken both machine learning and distributed systems in the past decade. It's been a whirlwind.
Nice. That's really impressive. I guess from academia to engineering, research, why VC? Right? I don't think I've ever asked you this. Why go into the venture? Why not be an entrepreneur? You could have gone any path, and VC is a very interesting one, but based off of your background.
Yeah, I mean, I think I guess my journey of foray into startups, it was largely revolved around deciding on working with people I really admired and wanted to learn from. Part of what I came to understand is I didn't really have a very good picture of what allowed certain startups to win in terms of how they strategically positioned themselves, in terms of the markets they went after, in terms of how they fit a technology to a market. And it's been a great learning opportunity to get a better sense for the answers, or at least the partial answers to some of those questions. I think I think the other bit is it's been, I think over the past couple of years especially, and you guys are certainly aware of this, is there's been a blurred line between research, products, startups. It's been fun to continue to be able to read papers and engage in some of the research that's been coming out recently, and how that allows you to rethink the product experience and rethink what consumers and customers are going to be using at the end of the day.
That's got to be the coolest thing, which is research to production has always and historically been very difficult, right? Microsoft, Facebook, bunch of companies where they have a research division, right? Whether it's FAIR, whether it's MSR, and a lot of papers are generated, but the hurdle to get that into a product was usually like a sometimes even a multi-year journey, and most of those research don't even get implemented. And so I started my career also at Microsoft, and at Microsoft we built a database based off of this paper on BW trees for distributed databases and how to do quick queries with it. And from that to a live product was gotta be like 4 or 5 years. And nowadays it's crazy where it's like as soon as a paper hits, some company in the AI space is trying to implement it and take advantage of it in like, it's got to be a month now or less, and they're going so fast. Where I think research is now getting paid even more to bring this insights because their novel ideas are going directly into production. Yeah.
Absolutely. No, it's been. I think the infrastructure and ecosystem, around these releases has really matured. Now you have folks releasing, open source models like with tweets or on Hugging Face, and it's immediately something that you can use with inference libraries and things like that. I think it's also been kind of interesting to see how this has matured, in the sense that a lot of systems research and really influential systems research was done in these academic labs, and part of the reason for that is I think there's a couple. Like, one is you have the resources to try a lot of different things. Like, you have a lot of compute, you have a lot of potentially headcount, like you have and you still have the flexibility to kind of explore ideas. There have been a lot of very, very influential works that came out of Google, Amazon, Microsoft. Like, I guess like Cosmos is like large CV, like DynamoDB. The paper was a fantastic one. Spanner. There's a
Spanner paper was great. Still, I don't know how it's gonna fully apply. I think in the Spanner paper they used to have, what is it, true time using satellites, nanosecond synchronization across clocks, across machines. Super cool, but
and
really hard to see why I need a satellite.
And you end up having like atomic clocks after. So I think the thing that I've been feeling more and more is, and it's become more apparent, is some of the stuff now extends to machine learning as well, right? Like a lot of machine learning work, I guess over the past decades, it's required more and more compute, but still accessible and approachable, to academic research labs, and now you have massive fundraisers and massive like cluster build outs, and that's kind of part of the recipe for what it takes to build stuff at the frontier at this point. So it's been interesting to see I guess part of what happened in systems research in terms of more and more research being proliferated from academia in industry to a kind of similar trend in machine learning.
I'm curious to get your take on an interesting thing, which is, you've been in the ML space for a while. You know that companies like Google are basically making billions off of their ads models, their search recommender models. But for the most part, a lot of companies not in the tech space, we're not really making that much money from ML, right? Some insurance models, some financial models here and there, but generally machine learning was more of a, what I like to say is it's mostly like 3 layers away, right? So when you sell a core machine learning product, you need then the either data scientist or some type of algorithms team, the data team, the engineering team, and some infra team to agree to it. And then they need to work with the product teams, and then they need to see the value add. And it was always 2 to 3 degrees removed. It seems like things have changed quite a bit nowadays, where the people with budget, which are usually the product teams, are the ones that are seeing the end to, like, they're basically just getting an endpoint, and they're saying, okay, I am able to use, whether you call it ML or AI, directly and yield value out of it. And so I'm willing to put the budget forward for that kind of product, right? And it started with GitHub, Copilot, where people are like, engineers are becoming more efficient. Nowadays, it's some type of AI capability, Notion AI. Google Workspace has Gemini across the workspace. I'm curious to kind of get your sense of what is that impact and how are you seeing it across the AI industry, which is people are, I guess, going more up, where it's no longer the right persona is sell it to the back-end teams who are going to evaluate it for how good it's ML. It's mostly like show the power directly to the product teams, because they're the ones that are gonna make the call on whether the budget's there or not.
Yeah, I mean, I guess there's a good amount to unpack there. I mean, I think first, the first order bit, or the first thing I would say is, I guess part of what you're mentioning, I think is true, which is that behind the scenes, advanced algorithms and data-driven decision making has really shaped the product experience broadly. Even going back, pre-LLMs.
Yeah.
If you look at like feed ranking in Facebook, I mean, Netflix had like a Netflix prize. It was $1 million prize for building better recommender systems.
That's right.
And Google's targeting and things like that, are, I'm sure, partially dependent on understanding the user based off of what's interacted with and what's expressed, right?
That's right.
So there's been this capability that's orchestrated the product experience and the product profitability, like the operation margins, like things like that, like behind the scenes. I think one of the things that has certainly changed is a very, very direct experience between the users and the models themselves. You can put a model in front of a user and it could still display value, right? You can, whether that's modifying photos or generating content, using it as a direct Q&A kind of experience. Like there's certainly a lot of new things that can be done, or at least scaled in a way where you may not require a lot of the ancillary components, like the things like the underlying user data, the databases, the level of compute that you might have on the back end. You can ship a model to a user's laptop or maybe even their phone now, and they can directly gain utility from interfacing with that model, right? So I think that's certainly something that seems different from before, but I do think that a lot of the experiences and products that folks resonate with the most are still cases where this model is allowing for a richer experience once integrated into an existing application. Like some of the ones you mentioned, I think are good examples, but whether it's for software development, whether it's for broad knowledge work, for note taking, things like that. Like I think there's a lot of cases where the model is not the full experience, so you still have this kind of necessity for bringing forward a lot of other components in the experience for the user. But even standalone, I guess right now the models themselves are really fun to play with.
So this is a really interesting point, which is historically, if I were to categorize the use cases as depth versus breadth, historically it's always been depth for ML, right? It's all about optimizing accuracy, where we would spend countless hours, weeks, days, months to just constantly improve accuracy of some of the models that run within a Netflix, a Facebook, or a Google. But what really made it catch fire, some can argue, was breadth, where it was, for the first, I guess the real caught everyone's attention was ChatGPT, GPT 3.5, and what was really remarkable was you can give it such a diversity of questions and it can respond with something that was good enough. Right? The models are significantly better now, but to start off with, it was just look how remarkable it is for how many things it can do, right? Even if it is, at that point, it was hilariously bad at math. It was very bad with any type of encapsulation of, let's say, phone numbers or anything else. It would mix up the digits. It would have all these problems, now mostly fixed. And so I'm curious, is the way of AI forward is it still a breadth play, or will it switch into a depth play where people are gonna now really prioritize really, really impactful use cases that they want to optimize? Which way do you see it, And
it's a good question. I mean, I think it depends on who you are, right? Like I think if you are a model provider, you're benefited by producing, one of a very broad and general purpose technology, right? You want to enable, similar to folks that build chips or compute, right? Like a lot of the underlying compute substrates that we leverage, they're general purpose. Like you can do a lot of things with them, and you don't have to necessarily acquire, a new technology to support a specific application. For model providers, there certainly is a great benefit to building out their technology as being general purpose while continuing to, push the frontier of capabilities, right? I think for folks that are building applications and are building, specific utilizations of that technology, I actually think it's the job is actually not that far off from the cases you alluded to that existed before, right? You have a way of doing things in terms of developing better and better machine learning systems. You have a training set and a holdout set, and you have a set of benchmarks that guide which weights you're going to select for the model that you present. And then between that, you have a lot of experiments that either revolve around getting more data, changing the model family or archetype itself, re-architecting the objective, like things like that. Like a lot of those things, I don't think they've really changed too much for the folks that are developing applications. And I think it's actually one of the most important things for folks to kind of consider on the application side is really putting together a harness for evaluations and benchmarks. Especially given how fast the pace of which things are released. At this point in time, having a good sense for what model in what situation provides the best opportunity for customers and users. It's still manifests as a data science problem. Right. Like as a problem in the way we just described. So I think having that muscle and being able to draw from those experiences actually still is very, very important for folks that are not seeking to build out a very, very general purpose technology. Folks that want to satisfy a specific customer for a specific task, and maybe that task is not recommendations, but it can be represented in a very specific way, and it can be evaluated, right? So I actually get really excited about the opportunity for folks that have that experience or have the desire to go down that path and really, really push on not just underlying model quality, but the resulting artifacts of doing things like fine-tuning models and leveraging user feedback and using reinforcement learning to guide how a model displays its outputs. So those things are still incredibly exciting.
I love hearing that. It's fun because I think the fun thing about it is almost it feels like people are learning the first principles of data science in a reverse order, which is so interesting, right? So think back to about a decade ago when you first were training your first model, right? You are doing some feature engineering, you're cleaning the data, you're splitting your data set into your test, train, your validation, you're thinking about model architecture, you're running it and you're iterating, you're experimenting. This is reverse, which is build an application with a model. Damn, it's just a little bit off. It just responded not how I wanted to. And then you kind of go into it and you're like, okay, I read somewhere that there's a better model for this. How do I compare it? Well, intuitively, I need to ask it the same question, so I want to do it. And now you're just rediscovering what experiments are. And then eventually you kind of get back more and more until you've reverse engineered what data science have been doing upwards. And there's something beautiful about that, which is, I think the most beautiful aspect of it is you know that the value is there, and then you work backwards, as opposed to traditionally how it was, which was you had to know within the research that this will work and there is precedence for it. And so I'm going to spend, I don't know, probably took month, 2 months, 3 months to build a high quality model for production, for churn prediction, for spam detection, something like that. But you had to know that it was there. You had to have the conviction that this is the way to do it. I've seen other companies do this type of strategy and get to really good results. I'm going to push for the next 3 months on this. Yeah. And that's so fascinating as I've seen the industry change, which is remarkably different. Nowadays, it's like I've seen it, now I need to reverse it, which is why people have that last mile problem, which is that last mile problem only exists because you've seen so much goodness up front that you're like, I see value, like it's a no-brainer. This will help our company, but then you need to rediscover all of data science and machine learning to get there.
Yeah. I mean, I think it's certainly like really interesting how much things have changed in terms of, I guess, like how you prioritize things from the beginning. Yeah. And it part of it is kind of, I think, what you're mentioning, which is the first offering that you deliver to an end user may be an unoptimized model. It might be an off-the-shelf model, right? And I think one of the things about that is it's actually, if you look at like the prior kind of history of those technology companies that built very, very good machine learning experiences, like companies like Netflix and Spotify. Yeah. Right. The path to get there, you didn't start off by offering an AI experience. No. You started off by offering an experience that was incredibly good, and it was good to the point where you were able to acquire a lot of user data. Yeah. A lot of preference data, right? And I think now it's possible to build, bootstrap that experience where you start off with, maybe not like an optimal or ideal experience, but you start off with an experience that already starts delivering value, from day one, right? And what that means is you have the ability to attract, users who will ultimately get you, the feedback and the data that will continue to drive that product experience, right? So I think that's kind of one aspect is a lot of prior companies that relied on ML. Like it's hard to imagine building a good ML experience from day one. Yeah. Right.
There's no cold start problem.
Exactly. Yeah. Exactly. Yeah. So it's that's, I think, one of the largest things that's been opened up, and you do end up running into that last mile problem that you mentioned, where once you have that data, you're now set with the task of going back to the data science problem of how do you get that next 9 in accuracy. Yeah. Right? That's been
next 9. It's like getting usually the first 9.
Yeah.
I think we typically see it hover around high 80s, low 90s. Mm-hmm. So if you want that either first 9 or second 9, you have to work for it. Yeah. Or you can just add a human in the loop, and then you'll end up questioning. Yeah, is this AI or is this a person? I'm curious, taking a step back, just you have privy to view the entire landscape of AI, which is so interesting, and it's changing so fast, right? Anybody I talk to in this space is saying, unlike anything else, it's changing every probably 3 to 6 months. Something pretty substantial happens in the industry, and it's really exciting. And as an investor, especially as kind of a seed state investor, mostly seed, also A and onwards, but you need to make some really bold predictions. It's a very scary position you're in, which is trends that you witness and saying, in 5 years, 6 years, I think this is going to really play out and it's going to hold. So I guess 2 questions. What are trends and bold predictions you have for, I guess, the next I'll make it easier. 3 years. And then the second question is how do you know?
Yeah, I mean, maybe I'll swap the order and talk about, some of the things I look at and think about, that help inform where things are changing or where things like might start to change. I think one of like the sources for inspiration on what kind of assumptions or bottlenecks might exist today that may be gone in the future, I think comes from the underlying infrastructure that application developers have access to.
Yeah.
Right. And I mean, I think this is a historical thing.
Yeah.
You'd never think about building a company like Uber before smartphones kind of come out, right? And I think
smartphones and GPS.
Yeah.
Satellite.
Yeah, exactly. Always on internet.
Yeah.
This kind of stuff, right? And I think on the model layer and on the infra side, we've been benefited to see, like we mentioned before, like there's just a really rapid pace of new developments.
Yeah.
That bubble up and propagate to users. I mean, I think there's a couple of things that have specifically caught my interest like recently. I think I guess even maybe this past week, like there's been a lot of with 3 models with incredible image generation and understanding capabilities that have come out.
Yeah.
Before that, I think there are a couple really exciting things on the model side. One is these reasoning models and the ability to basically like induce and then observe the chain of thought processes that language models are now generating. That's really exciting, and it's a departure from prior models where you have an impulse to, given a question, take a best shot at an answer and generate the response directly. And I think that additionally, like we've had some really phenomenal open source models come out. Really high quality open source models come out. So I think there's a couple of things that I'm specifically interested in and excited about right now that at least partially are kind of dependent on the observations of what kind of stuff has made its way out to the world on the infra and model side. I think one that I would say is incredibly exciting is education broadly and education tech broadly. I think that the ability to have a model that reasons through an answer, show the intermediate steps in a form of logical reasoning,
like a proof.
Exactly. I mean, this is one of the ways you kind of learn I guess like higher level math or coding. Like you end up in the mathematical sense, for proof-based math, you go through a series of steps, and in each step, you build up a new set of statements that is entailed based off of the prior ones. And I think in general the point is users that have access to a tool like this can learn from that chain of thought, right? And I think in general the ability to produce experiences that help students or whoever it may be learn a new topic. That kind of experience I think will change pretty drastically. There's been some kind of early signs that this is already happening in some specialized cases, but I think more broadly the opportunity afforded by what's typically a physical service in the form of a tutor or teacher or professor, those kinds of experiences can be more broadly propagated over the internet, right? So I think that's a space that is exciting, and I would love to kind of see that application out in the world in a variety of forms.
Do you think it might go down a similar path to chess, where I think right now the best chess models, like I think it's Stockfish. it's used as a teaching mechanism even for the best chess players, where
exactly
they're learning
right.
from it.
That's
But
exactly right.
one part it's grim, which is,
Yeah.
I think even the best chess players feel that it is almost, if not impossible, to beat
Yeah.
these models.
Yeah.
And so it's mostly to learn to compete with other chess players.
Yep.
Which is a grim side of it. The other side of it is the amount of new strategies and techniques that's learned is immense, because it has a lot of novel insights that's hard to derive through books and different ways of learning. Yeah.
I think it's a really perfect kind of example. So I actually been trying to learn how to play chess and get better at chess recently, and I actually spent some time over winter break basically building an application that was driven by these kinds of reasoning models, and the way it works is the following. Right? I think there's a first kind of level experience where you can play against or observe the play of an AI bot in chess or Go or whatever else it is, right?
Yeah.
And even from that experience, if you reflect on the moves that are made, you may, and that bot is sufficiently capable. You may learn something, in terms of how to respond in a specific board state, right? The experience with, let's say, a chess tutor is a little different, right? What may happen in that case, depending on how the lesson is structured, is you might have someone not only show you what move, is a book move or optimal, or
historically, the right opening or the right end game.
Exactly. So that's part of what may be introduced, but the other part would potentially be something more like a chain of thought, which is this move is a good, board state for you to enter because, these are some of the things that you might look to do afterwards. These are some of the risks that you might expose yourself to by making such a move. So an explanation of all the possibilities that kind of encapsulate the move itself. So one of the things I wanted to try out, with these reasoning models is exactly this kind of setting, right? Because that would push, the experience further towards that of having, a person teaching you. So if you actually feed the board state itself to reasoning models, you can ask them to do this, and it actually works quite well. So I think like that is like one aspect of it, I think, which is you can push that experience beyond what we've seen before, right? And you can extend that to things outside of board games, to solving algebra problems and things like that, right?
The one final question before we close out the podcast is, do you think that kind of approach using a reasoning model can beat Stockfish? One that's specifically for winning at chess, which is kind of a big model, small model problem. It's like highly specialized. Stockfish is much smaller than an LLM these days. Could you actually use, or even a reasoning model, could you actually use a reasoning model to beat the best chess model out there?
I think it's possible. I don't have any proof that maybe in a specific case, like it's possible to find an answer. I mean, I do know there are some papers out that talk about training grandmaster kind of level models on LLMs themselves, right? Like, or on transformer architectures, right? Like, so there are some kind of really interesting research works. I mean, I think a lot of, again, this kind of comes down to what model you use and how you construct that experience. Probably depends, a lot on the application area, right? Like whether it's chess or whether it's some other subject that you may be exposed to in school. The choice of model will probably largely impact the quality of the education you get from that model, I guess. Yeah, that's right. Amazing. Well, thank you so much for joining us for this podcast. It's
It's great to talk to somebody who's so deep in the research side, the AI side, and the VC world. And so it's amazing. Thank you, Vig.
Thanks for having me here.
Amazing. Thank you for joining us.
Thanks.
Bye.